right. All right, everybody, welcome. This is Tuesday. It's Tech Tuesday. It is another IAEI News Live. And my name's Thomas Dimitrovich. So today is, hopefully, you got out and voted today, because today is election day here in the United States, at least. Hope everybody is doing well. Close this. And what's this? That's a Zoom account. All right. So network cameras. I don't have any network cameras. So we're live. Okay. What I thought I would do today is take a look at the 2020, or no, what am I talking about? Controversy. It's a controversial day for a lot of people. Thought I'd pick a controversial topic. There's phrases inside of the National Electrical Code where we say things like, where justified energized or where energized work will be performed or whatnot. So my thoughts were to explore that a little bit. What do we mean by energized work? All that good stuff. Hey, David Engelhardt, grateful for on-demand availability. He's virtually attending a fire safety inspector continuing education today relative to the 76th Annual Florida Fire Prevention Conference. Well, David Engelhardt, we're going to miss you, buddy. We will definitely miss you. All right, so I got that up, and I'm going to close this. Laurel, looking forward. Excellent. Yes, Laurel. So here's the thought process. I mean, if you take a look and grab NFPA link, Keith Wilson in the house. Thanks for joining in, buddy. And we got Yummy Fudge from Utah. Town Council for the Electricity. Oh, excellent. I got on the agenda from my Town Council for the Electricity Initiative. Excellent, Yummy Fudge. You are the man. Really glad to see. Really glad to hear. I wish if there's anything I can do to help. I don't know I don't think I can do anything to help. I know Rudy will help. So, yeah, good luck with that. And make it happen, brother. Make it happen. All right, so why this topic? I'll tell you, I was in Article 110, and I was looking at 110.24, I think it was 127, spaces about electrical equipment. I had a question about working space from an individual. And I thought, well, let's take a look at some of the language. So we pulled up the language together. And we looked at the parent text. The parent text said working space and access to and egress from and all that jazz. Let me do this. I'm going to move this over this way. I'll pull this up a little bit. 110.26. I hate when I do that, when I resize. And then, that's 110.27. All right, 110.26. And you got to have hopefully you have your NFPA link available. I get come on, here we go. If there's any content out there, numbers or notes or presentation decks, he would love to see and use them if they exist. I'll reach out to Rudy Garza. I'll shoot him a note and see if there's anything. Happy Tech Tuesday. One of my favorite ways to win an argument. Not likely to be worked on while energized. I know. So here's the discussion that I had. I was in 110.26, which is spaces about electrical equipment. And they're talking about access to and egress from. And in A, it says working space for equipment operating at 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. And I started to think, when would you not need to examine, adjust, service, or perform maintenance while energized? I was intrigued. So I thought this is my thought on it from a journey perspective. We should look at understand what is energized work. What do we mean by energized? Where is it used in codes and standards? How is it used in codes and standards? And then how do we leverage, or how do we enforce it? I mean, that's really my third bullet point there, is how do we enforce when someone says this is not likely to be worked on energized? Is that an opinion? Is it fact? Is it documented? That's sort of where my head was at. I don't know how I would do that. So my first step was to say, well, what is energized? And if you look at the NEC says energized is when you have something that is electrically connected to or is a source of voltage. So you have to have a voltage potential. A non-fused disconnect is a good example. All right. Okay. So a non-fused disconnect. Let's take that thought process. If I go to, let's just look at NFPA 70B. Let's go to NFPA link. And what I love about NFPA link is you have access to all of these documents. I cannot say enough about how much I use NFPA link. So if you think about NFPA 70B, NFPA 70B has a lot of information. We have our general requirements, we have personnel safety, we have single line diagrams, fundamental tests, we have maintenance intervals, and then as you go down through here, switches. So basically, the non-fused disconnect would be a switch. So what I want to do is I want to take a look at what are the requirements in 70B for maintenance of a switch, and are there any maintenance procedures that are required to be done while energized? That would be my discussion point. So let's look at visual inspections. Visual inspections. Remember, one is energized. One is energized. Two is in an electrically safe work condition. So if I look, I'm going to just walk through the visual inspections on a switch. Is there anything we have to do that is visual that would have to be done while it's energized? So we have inspecting the doors and latches. Let's take a look. We have first inspecting the doors and latches for fit. Now that's a 1 or a 2, so that can be done energized or in an electrically safe work condition. So I would argue that we would want to do this in electrically safe work condition. So I do this in a 2. I don't need to energize for that. Inspecting insulating materials and switch base for physical damage. Inspecting the wiring, bus, cables, and connections. So I would establish an electrically safe work condition and then open it and look at all of these items. So I don't see anything in that list that I would say needed to be done while energized in a non-fused safety disconnect switch. How about cleaning? I would not expect any cleaning. Felix Sandoval in the house. Glad to see you, buddy. Hey, Steve. Yes, I tell you what, Steve, I thought this was going to be an interesting topic on an interesting day here in the United States for election. It can be controversial. So how about cleaning? So there is nothing. Everything is a 2. We have to clean the switch and the barriers. We have to clean exposed contacts. We have to wipe the contact surfaces with a lint-free cleaning cloth. All that good stuff. So nothing in there needs to be done while it's energized. And the point of discussion, Felix and Steve, for anybody else who's come to the table a little bit late, Willie Snyder said, hey, a good example of a product that is not likely to be worked on energized or maintained, etc. The way the language read in working space, it says, or less to ground, and likely to require examination, adjustment, servicing, or maintenance. So we're looking at examination. Would I have to examine it in an energized state, make any adjustments, or do any servicing while energized, or maintenance? And then examination. So what I'm focusing right now is, I just said, I know maintenance is something that I can wrap my head around, and we have a document associated with it. So I pulled up NFPA link, and I am walking through chapter 17, which is focused on switches. We've looked at visual inspections, we've looked at cleaning, and now we're looking at lubrication. And I don't see anything in lubrication that would need to be performed while energized. And then I'm looking at mechanical servicing. So mechanical servicing is the next category of maintenance that would be performed. And all of these are 2s. It says, if accessible, verify the main blade alignment, penetration, travel stops, and mechanical operation. I don't need it energized to do any of that. So I don't see any of the items in maintaining a switch that would require to be energized. All right, so let's go down to the electrical tests. Okay. Now, electrical tests. So there is one test in here that would be required to be performed while energized, and it is thermography. Now, let's talk about thermography. Can someone post the document section he's reading off of? Internet pooped out for a second and I missed it. I'm reading out a table. I'm in chapter 17 of NFPA 70B. Yummy fudge. And I'm looking at, I'm in 70B, so you would call up your NFPA link. I'm in 70B, and I'm walking through the different maintenance on a switch. And I didn't see anything on visual inspection, cleaning, mechanical, or lubrication. So those 4, nothing that would require you to have a disconnect switch energized. In the electrical maintenance, in table 17.3.5, the only thing in there is infrared thermography. Now, I'm required to do infrared thermography. And let's think about this. Infrared thermography. Now, what you could do. Now, think about it. When it comes to a switch, to perform infrared thermography, if I don't have, and I'm going to find it here, AC disconnect switch, there are, I'm just going to come up here and I'm just going to look and see if I can find there are solutions out there There it is. I knew it was there. Look at this. Now, what this is, there are switches that you can get. There are switches where I'm going to do this. I just want to pull up the right. I'm going out to a website. It's pretty windy outside. I'm going to IRIS, IRISS, Infrared Inspection Solutions. They have windows. So these windows can be cut into any type of product. This is just one manufacturer. So if I employed a technology like this, then I could argue that you would not have to do, even in the infrared thermography, I would not have to open the door to perform the thermography. Now, I have to be able to get there in front of the equipment to be able to do the infrared thermography. But again, we're talking about working space. And so I can have a disconnect. To your point, I can have a disconnect that I don't have working space for the disconnect, say a non-fused disconnect, but I should be able to address thermography, and I could put a window in there and say, look, there's no exposed energized work that is going to be performed, even in the case of thermography. So I would say, I could argue that based upon that language, for working space, likely to require examination, adjustment, servicing, or maintenance while energized, and maintenance would be thermography. If I had to perform thermography, it would have to be done while energized. I would have to expose energized parts. And if I don't have enough working space, if I have a disconnect switch, I've got a picture. I have a picture. If I can find it, I have a photo that will, oh boy. Let me see if I have pictures. I know I was in Alabama when I took the photo. I was in Alabama when I took this photo, and I thought it was funny because you may or may not know Donnie. Donnie was walking in between a piece of equipment, and there was a disconnect switch there. And there was no way there was enough working space for that disconnect switch. And it was just it was a great photo because it was the epitome of working space. And if I can find it, I'm going to look here while I'm talking. So the one of the things to remember is that you have to think about all of the aspects of when we talk about energized work. Maintenance is one of those aspects. Thermography is one of those areas that will have to be performed on equipment. And if you have to open the door, now the fact that you're opening, now you could go through a procedure and say, I'm going to open the door, turn everything off, open the door, turn things on. And then remember what it says is you have to achieve a certain amount of current passing through the terminations to get a reading for thermography, because you've got to have enough current flowing for enough time to generate heat in the terminations, which you will be performing thermography on. So, and I do not have that photo, but it was a beautiful photo. I just looked through all of my Alabama photos, and I probably offloaded it to a different backup for space requirements. But anyway, Robert from Omaha, greetings and salutations. All right, so now working space, if you have a AC disconnect, I would argue maintenance would be the tough one for that. But if you had the IR scan windows, you would dispel any possible. If you have a non-fused AC disconnect, you're not doing any justified energized work on it. It is not likely to require examination, adjustment, servicing, or maintenance while it is energized. So, and like I say, if you have that window, IR scan window, and you scan through the window, you're not exposing anybody to any energized work. Another example is if you have to shut off the switch to open, granted the line side would still be energized. Well, that's still energized work, so that would still be examining, adjusting, servicing, and maintenance while energized. So it doesn't matter if it's barriered, because remember, what is energized? We just saw the definition of energized, and that was electrically connected to or is a source of voltage. So if you're electrically connected to a voltage source, then you are energized. If you open that door, whether the switch is in the off position or on position, the moment you open the door, you are conducting energized work. But now let's talk about that. Yeah, got to hit that like button. Come on, guys. Got to hit the thumbs up. Remember, thumbs up. I don't know if it'll do it. No, thumbs up. Don't forget to hit that thumbs up. Don't forget to smash that like button. So let's talk about what is work. That's another point of discussion. If you think about 70E, I'm going to go back over to NFPA link. When you think about 70E, what is work? I don't think, like working on. Let's see if it's a defined term. Let's go to W's. W's, QRSTUV. There's not working distance. Working on is a defined term. All right. Let's take a look at what is the definition of working on. It says intentionally coming in contact with energized electrical conductors or circuit parts with the hands, feet, or body or other body parts, intentionally, not by mistake, with tools, probes, or with test equipment, regardless of the personal protective equipment the person is wearing. So 110.26 says likely to require examination, adjustment, servicing, or maintenance. So it doesn't even say working on. Servicing, adjustment, examination. So I can't even go to working on as an example for that. So I mean, it's an interesting term to be aware of, but I don't think working on. Looking at the informational notes, clarification 2 types of working on. Informational note. Examples of working on can include, but are not limited to, diagnostic testing, such as taking readings, measurements, conductors, circuit parts approved, or repair a physical alteration. Now, here's the other aspect. Let's talk about infrared. IR. If you think about, let's talk about when is it required to establish an electrically safe work condition. 110.2c in 70E not that one. We have 130. 130.2 is Energized Electrical Work Permit. Remember what an Energized Electrical Work Permit is. Let's do this. What an Energized Electrical Work Permit. It tells us when it's required. It tells us what all the elements of a work permit are. So let's talk about what the elements are. You have to have a description of the circuit and the work to be performed. You have to have justification on why you're going to do the energized work. You have to describe all of the safe work practices that you're going to employ. You have to conduct and report the results of an electric shock risk assessment and an arc flash risk assessment. You have to have means employed to restrict access to unqualified persons, so those are your barriers. You have to have evidence of the completion of a job briefing, and then you've got to have approval, a documented approval with signatures of the energized work. That would be your permit. Now there are exceptions. Now let's take a look, because I thought the exceptions were exceptionally interesting. Testing, troubleshooting, or voltage measuring. Now, thermography is one of those. Ultrasound or visual inspections if the restricted approach boundary is not crossed. So now I can conduct thermography with the doors open and say I don't need an energized electrical work permit if I am doing thermography. But what about the act of opening the door? I mean, I am exposing electrical parts. What you could say, because once you have exposed electrical parts, you are in an area of energized. That's energized work. So and a good example of where the hazards may lie. If I am going to take, say, a panel board and I'm going to take the dead front off, or say that safety disconnect switch has a barrier in there, opening that door, I could cause an arc flash event because of the fact that, poor maintenance on the equipment, etc. But so it is possible that I establish an electrically safe work condition, I turn the switch off. Oh, man. Robert, let's talk about this one. What about if I have, what if I, what establishing an electrically safe work condition when I verify absence of voltage, is that energized work? I gotta look back. I gotta look at the comments here. Hold on. Let's take a look. Let's take a look at what do we got? Can someone post the document? All right. Hey, Tom Robert from Omaha. Willie Snyder. Hey, Jake. Another example. Okay, 14 watch only hit. Already liked. Excellent. Steve. Education. Robert. Great point. Any time there is energy in the box, it's energized. Working on, look at the info note for clarification on 2 types of working on. We did that. Are you in the boundaries established for shock or arc flash? That's true. When you're going to expose energized parts, you have to do your shock risk assessment, your arc flash risk assessment, and all that jazz. But what if, Robert, I'm trying to determine if I go upstream and I turn that disconnect switch off. I go upstream to the fusible switch or breaker that is supplying the disconnect. I turn it off. I lock and tag it out. Then I go down to the switch. It should be. It should not be energized, but I'm taking a big, it's a big should be, right? I have to verify absence of voltage. Is that verification process energized work? Is verifying absence of voltage considered energized work? If it's not considered energized work, then I wouldn't need PPE. But I believe even 70E tells you that you need PPE when you are verifying absence of voltage. Where did my... There it is. If I go to NFPA link and I go to 70E and I come over to Article 120 is you're establishing an electrically safe work condition. You have the lockout tagout. You have the employee responsibilities. You've got the lockout tagout procedures, controlling all of your different energy. You got your equipment. I'm just looking in 120 on 70E, locating all the sources, complex and simple. Disconnecting responsibility. Testing. Test instruments to be used, the required PPE and the person who will use. So the procedure shall establish, this is for testing. Requirement to define the boundary of electrically safe work condition. Requirement to test before touching every exposed conductor or circuit parts within the defined boundary of the work area. Requirement to retest for absence of voltage when circuit conditions change, and then planning considerations include methods of verification. But the first point of this is test instrument and the PPE that you are going to need. Processed. So the process for establishing an electrically safe work condition. Establish and verify. Here's what I'm trying to do. I'm trying to determine, is there a case where you would never perform energized work, even if you're going to establish an electrically safe work condition? So if I take a panel board or that disconnect switch and I am going to turn it off, because remember the maintenance, we said we have to clean it. So we know we have to clean it. We know we have to visually inspect it. And all of that can be done when it is not energized. But is there any part of de-energization, of establishing an electrically safe work condition that would be considered energized work? That's my question. I don't know the answer to it. I'm just asking the question. So I'm going to 120.6. So our meters have to be rated for transients when we need to be protected. That is for shock. What about arc flash? And have as part of the briefing an emergency plan. Section 110.2c shows how to consider until electrically safe work condition is verified. 110.2c. Yummy Fudge says if they pull the meter and that is the only source of power. Okay, well, so Yummy Fudge, if it was my dwelling unit, I would agree with you. In a large commercial or an industrial establishment, man, you got to be sure you got all of the sources. There might be multiple meters. I don't know. Laurel, very good point on electrically safe work condition in 2470E, 110.2c. Yes, if the device is controlled from an automated controller, VFD. I'm not sure what that means. So let's take a look. The process for establishing. So, 1, you have to determine all possible sources of electrical supply to the specific equipment. Check applicable up-to-date drawings, diagrams, and a tag. So just gotta make sure you have all the sources. After you properly interrupt the load, that would mean you're disconnecting the safety disconnect switch. Open the disconnecting devices for each source. So if I have that disconnect switch and I have a circuit breaker, I would open that. Wherever possible, visually verify that all the blades of the disconnecting device are fully opened. Well, if my breaker, if it's a multi-case circuit breaker, I don't have visual indication, so it wouldn't be possible. Release any stored electrical energy. Now, if it was a power breaker or an insulated case circuit breaker, I don't want to charge that handle. I want to make sure that all the stored energy is released. 5 is block or relieve stored non-electrical energy in devices to the extent the circuit parts cannot be unintentionally energized by such devices. So if it's a molded case circuit breaker, I don't have to worry about that. Apply your lock and tag out devices in accordance with documented and established procedures. So now I'm going to have my lock and tag on that overcurrent device. And then it says use an adequately rated portable test instrument to test each phase conductor or circuit part at each point of work to test for absence of voltage. Test each phase conductor or circuit part both phase to phase and phase to ground. Before and after each test, determine that the test instrument is operating satisfactorily through verification on any known voltage source. So I could have something less than 50 volts to verify that my meter is working. So I don't need to expose myself there. So that act of using the meter to determine absence of voltage. 8 says where the possibility of induced voltages or stored electrical energy exists, ground all circuit conductors and circuit parts before touching them. Okay, that's like your capacitive, I guess. You want to discharge all that. Where it could be reasonably anticipated that the conductors or circuit parts being de-energized could contact other exposed energized conductors or circuit parts, apply temporary protective grounding equipment in accordance with, you have the placement, the capacity, and the impedance. So is the act of testing for absence of voltage considered energized? You have to assume it's energized. And it could be if you didn't turn off the right breaker. Good topic. Never really dug into this in type of detail. I know, Yummy Fudge. Possible sources include induction. Right, Steve? You're absolutely right. You're bouncing around documents and sections a lot. I'm having a hard time following. Sorry, Yummy Fudge. Can you share your screen? I could do that. My only concern is, so here's what I'm doing. I'm in 70E, and I was looking at the process for establishing. I'm using NFPA link, so don't forget to get your copy of NFPA link. And I'm looking at the process for establishing and verifying an electrically safe work condition. So my thought process is, let's take that non-fused disconnect switch, and let's say it's got infrared windows on it. I know I have to do thermography. And if I go to 70B, it tells me that I have to do visual inspections. Let's do cleaning. Let's just take a look at cleaning. It tells me that I have to clean, so I'm in 70B now, and I have to clean the switch and barriers. I have to clean exposed contacts, and all of those are a 2, and a 2 means it's in an electrically safe work condition. So if on a non-fused disconnect switch, the only action that I have to perform, energized, is thermography, and I can establish an electrically safe work condition in all of these other cases, is the act of establishing, now I'm in 70E, is the act of establishing and verifying an electrically safe work condition considered energized work? If it is, then even that fusible disconnect switch which needs to be cleaned, while it is in an electrically safe work condition, that means that I have to, if I scroll down, if I consider item 7 to be energized work until I verified it is not energized, if I consider item 7 to be energized work, can I say that on that non-fused disconnect with the infrared windows, no work would be conducted while energized? I mean, if I look in Article 110, and I'm focusing on working space for equipment operating 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. Can I say that non-fused disconnect switch meets that requirement? I want to say it does. That's what I want to say. But the question is, can I say that? When I look at 70E, and when I look at 70B, so I've got three documents open here on NFPA Link, which is another value for NFPA Link. I look at 70B and it says I need to clean this thing. I need to clean the switch, the barriers. I have to clean the exposed switch contacts. That means I got to open that door and get inside. And it's got to be, I need to establish an electrically safe work condition. I go to 70E and it tells me to establish an electrically safe work condition, I need to determine all the possible sources. I need to interrupt the load currents, meaning I'm going to open up that switch. Wherever possible, I need to visually verify any of the blades. If it's a molded case circuit breaker upstream, I'm just going to turn the breaker off. I am going to apply a lock and tag out device, and then I got to go back down to that switch, and I need to take a test instrument, and I need to measure the voltage at that switch, non-fused disconnect switch with the door open. I cannot say that I have achieved an electrically safe work condition until I've verified absence of voltage, and I have to consider it is energized until I verify. So is that energized work? All right, let's take a look at Yummy Fudge. Hopefully, Yummy Fudge, I helped you out there a little bit. Transformer is another good example. Working on shows diagnostic is working on. But remember, in 110, it didn't say working on. It just said visual. I mean, it just, while energized. Yes, testing for potential is considered energized work. Andrew Casney, I would agree with you. Testing for potential. If it's considered, Andrew, if it's considered energized work, then how the heck do we in 110, I'm looking in 110.26, 110.26, spaces about electrical equipment, working space and access to egress from working space shall be provided and maintained about all electrical equipment, blah, 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 open equipment doors, etc. Working space for equipment operating 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized. Maybe it's the while energized, Andrew. Maybe that's the part that gets me out of having working space on a non-fused disconnect. Am I going to examine it, adjust? I'm not going to adjust. I'll have to verify absence of voltage. I'm not going to be performing maintenance while it's energized. So I can strike that off, maintenance while energized. I can say I'm meeting that. I'm not servicing it while it's energized. I'm not doing any adjustments while it's energized. And I'm not going to examination while energized, verifying absence of voltage. That wouldn't be examination. I'm doing a verification. So I would tend to agree. I'm leaning in. I'm leaning in the court now that for working space and other places where we use this phrase, likely to require examination, adjustment, servicing, or maintenance while energized. Maintenance, I may have to establish an electrically safe work condition beforehand, but I'm not going to be maintaining it while it's energized, that disconnect switch. I'm not going to be servicing it while it's energized. Servicing it is a defined term in the National Electrical Code. I'm not going to be doing adjustments while it's energized based on 70B. And I will not be examining it. The only thing I am doing is verifying absence of voltage. And I would argue that is none of those. So I don't need working space for equipment operating. I don't need working space for a non-fusible disconnect with infrared windows. I'll throw that in there. Operating at 1,000 volts nominal or less to ground, because it is not likely that I will be examining it, adjusting it, performing service on it, or maintaining it while it is energized. I will be verifying absence of voltage, but that is not one of those 4 items that are conducted while energized. So verification of absence of voltage is, to Andrew, to your point, it is energized work. I would 100% agree with that statement. But I am not performing any of those other ones while energized. Yummy Fudge, that helps showing even that. Thank you. You're welcome. Robert, definition of working on. Robert, to do thermography, you have to have it energized. Or what are you going to read? You're absolutely right. And closed doors are not a guarantee of safety all the time. I would agree, Robert. But if I can perform the infrared thermography outside of the arc flash boundary, I'm definitely outside of the, well, I'm not definitely outside. I have to be outside of the shock boundaries, right? So I have to be outside of the restricted and the, you got the restricted approach boundary and the, man, what are my two boundaries? You got restricted and you have whatever the other one is. So I can do my thermography, but it's opening that door. It's established, and if I open the door and it's all energized, then I'm not going to verify absence of voltage. I'm going to open that piece of equipment. I'm going to step back. I'm going to scan it, and then I'm going to close the door. But if I have IR windows, I take that whole question out. I mean, I could see a debate going on if I look, and let's take a look at a transformer. Let's take a look at 70B. Transformers are covered in chapter transformers. In 70B, a transformer is covered. Where's a transformer covered? Hold on. All right, I'm going to start. I'm going to. We got 11 is power distribution transformers. Jeez, I should have gone. All right, so transformers. Frequency of maintenance. So visual inspections. There's nothing in visual inspections. So if I think about visual inspections, there's nothing in the visual inspections that is required to be performed while energized. Cleaning, lubrication, mechanical servicing, I would highly doubt there's nothing here that is required to be done energized. Electrical testing, let's take a look at that one. Electrical testing, no. There is nothing in there. they don't have IR scanning. No infrared. All electrical equipment has to be infrared tested. Let's see if they have anything up above. Periodic maintenance. Expand. Insulating fluid tests. So if I come up to chapter 9 and I look at, let's look at this. And if I look at transformers, QRS, I don't see transformers. I do not see transform. Where are transformers? All right, hold on. I got busway, I got cable tray, I have electronic, I got fuses, GFCIs, ground and bonding, I got lighting. I got medium voltage power breakers, I got molded case, I've got motor control equipment, panel board, switchboards. Power, there it is, power. There we go. I don't even have to do that. All equipment, right at the top of the list. All of the equipment, thermography, condition 1 is 12 months, condition 2 is 12 months, condition 3 is 6 months. So all electrical equipment has to have thermography. That would include transformers. So I would have to do thermography on a transformer. And if I have to expose, if I have to take those those covers off, I'm doing energized work. Unless I have those infrared, I tell you what, I'm seeing the value of IR windows more and more. So in both cases of the non-fused disconnect and a transformer, I get it. But the moment you start getting into other products, that's when you start expanding the your scope. You expand your what do they call that? Susceptibility or whatever. You're going to be impacted. All right, Felix. Oh wait, hold on. Wow, you know, if that helps show me. Okay, Felix. As far, I don't think you can do work without considering an energized unless you test the voltage. I would agree, Yummy Fudge. Felix, as far as I think, electrically safe work condition is. Yes, electrically safe work condition is your de-energized, but you have to follow the procedures for in Article 120 of 70E, an established electrically safe work condition, which includes the locking out and tagging out, verifying absence of voltage, identifying all the sources of power. All that whole process is establishing an electrically safe work condition. Remember that 70E 2024 section 110.2c says all of 120.2 to 120.6 has been met. That's right. You have to have all of those. Yummy Fudge, check the scope. Do all the scopes line up between all of these and when each requirement needs to be applied? You have if you're talking about the maintenance, you have the maintenance intervals established in Chapter 9. I believe it's Chapter 9 of 70B. David Engelhardt, break. We got David with us. All right. Felix, absence of voltage can be done without contact. Yes. It can be done with the right tools. But you are exposed. You have energized parts, Felix, that are exposed. And that's all I need. I don't need to engage. I have exposed, energized parts. Paul retracted his message. Keith Wilson, limited approach boundary. Yes. Restricted approach boundary and limited approach boundary. So you're saying if you are outside the shock boundary, you do not have to consider the arc flash boundary? Yes, you do have to consider the arc flash boundary. But what I meant was, Robert, I could be outside of the arc flash boundary but still within the shock boundary, because the arc flash boundary could be inches. Depends upon the amount of energy. So I can't just say outside of the arc flash boundary, because I could also be within, I could be within the limited approach or the restricted approach, but I could be outside of the arc flash boundary, or I could be inside the arc flash boundary, because it could be feet. It could be 10, 15 feet, depending upon how much energy. 70B 110.31 number 9 on transformer enclosures. Ooh, 70B. 70B. 70B 11.3.1 number 9. 11.3.1. 11.3. 11.3.19 transformer enclosure. You know what that is? That is a visual inspection of the enclosure itself. So what you're looking for there is the ventilation. You want to make sure that the ventilation is not obstructed, that the integrity of the enclosure has not been compromised. So that would be all the vents, all of the vents for proper air circulation, dents, and whether or not the actual physical outside of the transformer is intact. All right, so time is it? It's 12:58. So let's take the last few minutes here and let's think about. I think if you think, let's just think about where is that used in the code? That language. That language is used in 110.16 as well, the arc flash label. So in 110.16a, it says electrical equipment such as switchboards, switchgear, closed panel boards, industrial. I thought my Jakey was here. And motor control centers in other than dwelling units likely to require examination, adjustment, servicing, or maintenance while energized. So you have to put that arc flash hazard warning on that equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. It can be field or factory marked. Panel boards are no-brainers. That non-fused disconnect, that transformer. I would almost argue if you want to remove all doubt, put an IR window on there. You could have an inspector or someone say, well, how are you going to do the infrared? It has to be done while energized. And you're going to have to open that door. You're going to have to expose the energized parts to prepare for the IR scanning. I could see that debate going on. I don't know if it's ever occurred. I can definitely see that debate occurring. But 110.16 is another place where it is used. 110.26 we already talked about. 110.34, this, I think now you're getting into the medium voltage stuff. 110.70, electrical enclosures intended for personnel entry and specifically fabricated for the purpose be of sufficient size to provide safe work space about electrical equipment with live parts that is likely to require examination, and then the enclosures have to have sufficient size. And then 110.73, that's your medium voltage working space. It has the same language in there. So we've got to think about all of those areas in the code where that phrase is used, and then look at the equipment. Now, for a sticker, I would put the sticker on and call it a day. That's just that 110.16a is just your little hazard guy. I mean, if I can put a little sticker like that on for 59 cents or whatever it costs to avoid a discussion or a debate with somebody, I'm going to do that every day of the week, twice on Sunday. If I have to place a piece of equipment in a certain area and I don't have the working space, and I know I don't have that working space, that required 3 foot or whatever the space is for that application, then I'm going to probably say, okay, now I'm going to really dig into this to understand, is it likely to be worked on energized? Laurel, education power horizons. So really, I thought that's why they put small pinholes in the barriers to verify an electrically safe work condition without exposing energized parts. That's a whole nother subject. Because energized doesn't say exposed, right? So hold on. While energized. It doesn't say, so if I look at working space, and we'll go back to working space, Willie, it doesn't say while energized parts are exposed. It just says while energized. And energized is a defined term, which we said was energized, was my first slide, electrically connected to a source of voltage. So I don't care if it's exposed or not exposed. That language requires it while energized, just while voltage is applied. It doesn't matter if it's barriered off, finger safe, or anything like that. That's not the way the language reads. So that is I think it's an important distinction to think about. Class is starting back up. Hey, thanks for joining in, David. Tell the inspector I'm buying my equipment from Eaton to avoid an unintentional rapid disassembly in the field. You ain't right. You ain't right. There's something wrong with you. It's that's the elevation in Denver, Colorado. Before I got a drop, thanks again for the topic. This is a side of the requirements I've rarely had to work with, so it was a fire hose for me. Thank you, Yummy Fudge, but good to begin to understand. Yeah, you're on the tip of the iceberg. Just give you some food for thought. We didn't solve any world problems today. We brought up a topic that can be controversial to some on a day where we are at the polls. And remember, got to vote today. Don't forget to vote. Thanks for that clarification. Nihad, hey. Yeah, time change. It's exactly right. Also, if there's anything for electricity content, let me know who I can contact. I will see what I can find for you, Yummy Fudge. All right, Felix, thank you. Thanks, everybody, for tuning in. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe. Vote today. Get out there. Get out to the polls, especially if you're going to vote my way. And remember, vote in the morning, vote in the afternoon, and if you can get the vote again in the evening, do it as often as you can. All right, Laurel, thank you very much. Nihad, Willie, everybody, thank you very much. Take care. Stay safe. See you next week.